All right, good morning or good afternoon, depending on where you are in the world or when you're actually watching this video. I'm Jacob, and today we're going to talk about EPROMs. So, this is an EPROM. EPROM stands for Erasable Programmable Read-Only Memory. This one is erasable via ultraviolet light. And if we switch over to the Wikipedia page for it, you can see that, yes, you erase it by exposing it to ultraviolet light. It needs a very specific wavelength of ultraviolet light. So sunlight can erase it over a longer period of time, but there are erasers that are basically just ultraviolet lights in a box. So yeah, there's different packages for them, but they're all kind of the same. There's also EEPROMs, which are electronically erasable, and they have actually their own Wikipedia page. But those are a lot more convenient, and those are what's typically used nowadays because you just use your programming software to erase it before you write it. But these actually require ultraviolet light. So let's go back over. So yes, this is our chip. So this is what we're going to be doing today. I actually have an example of an EEPROM. So this particular one that I'm showing you on screen right now is a... Come on, get out of there. So this one is an ST branded M27C512. So, and then this one is a WinBond W27C512. So this is the electronically erasable. This is the UV erasable. So, so these are both 512 bits. So they are organized in 8 bits per byte. So these are meant for older computers that are 8-bit computers. Let's put this one away. I don't want to use the electronically erasable ones if I'm going to be soldering them to a board, because it doesn't make as much sense. I'd rather use these that are harder to erase. But it's fine. It's easy enough to erase. I have an eraser. So how do we program one of these? There's no USB port or anything like that. So what we use is a programmer. And this has what's known as a ZIF socket, or a zero insertion force socket. So basically what you do is you just lift up this lever here, and then you look at this diagram here. It says IC, and then it has a little notch on the image. And we're going to orient our chip, orient the notch that you can see right here. And we're going to place that in the furthest right. And there's even an arrow. It says, all the way over there. And we're just going to make sure it's in there, and then lock it down. All right. And you don't have to have this unplugged when you do that, but you can. I do. So unfortunately, the USB that this uses is the Type B connector, which, if you're of a certain age, you'll remember that from printers. I think some printers might still use it if they're not wireless. But so we're going to plug that in. Let's plug it into the computer. And you can see the power light came on here. So actually, one thing we want to do before we program this thing, because I've got some pretty strong lights, and they are fluorescent bulbs, so they do put off UV. So what I'm going to do before I mess with programming this is cover this little window with some foil tape. And I'm just using the kind of foil tape that you get for like from Home Depot or whatever, for working on air conditioning ducts. So yeah, it's just like aluminum foil, but it's adhesive on one side. So I'm going to place this on here. You want to make sure that you're not touching any of the pins with it, though, because it may be conductive and you don't want to bridge any of these pins. So yeah, now that's covered. Sometimes you'll write here's the version or whatever's on there. So yeah, this one has .cosmos on it. Really awesome indie developed game for the Commodore 64. And that's actually what this is going to go into, as a Commodore 64. Some people will actually take like digital label makers and they'll use the transparent or white or whatever to put a nice label on here, but I don't have one of those, so I could use my like punch one. But anyway, so yeah, now that that's in there, we're going to switch over to the software. So this is XGECU Pro. So this is the software that works with this particular device. This is the tl866ii Plus. That's what this particular device is that I'm using. I could actually... It's a little weird. The language is a little difficult to understand, but there are other video tutorials that I followed in order to work with this. So I'm kind of contributing back by doing my own tutorial. Yeah, so we already have our device set up. We need to go and select which IC we are using. So yeah, go to the IC section here and click the button, and then you'll search for your the manufacturer name in this list. Mine is ST, as I said before, and we're just going to go ahead and search for 27C512. And we can see that there is a 27C512 in DIP 28, dual inline package 28, and then there's a different one that's in a different package, but we're not going to select that one. We're going to select the DIP 28, and select that. Okay, so now that we've selected our chip from the menu, we want to verify that it's actually empty. So we want to go to Device and Blank Check. And just use the default options and click blank, and it will read through. So it detected the right pins, the ID is fine, and that, I guess it's making sure that it's the right chip. It checked the memory and it said it's empty. So cool. We don't have to erase this chip. It's empty. If it was a chip that already had something on it, there is a read button. You can read the data off of it, and that data will appear in this list on the left. Okay, so now that we've verified that the chip is empty, we can write something to it. And today I'm going to be writing a floppy drive diagnostic cartridge. So I'm going to go to Open, and then I've already got, this is actually the .crt file, which is not a security certificate. It's actually a cart file for Commodore 64, but I've already converted it into a raw binary file. And this is just, it's exactly just the bytes. There's no header information, there's no nothing, it's just the bytes. So we're going to open this .bin file here, and it is binary. It is not Intel hex. It is binary. And we're just going to do default here. Load mode is normal. We're not going to worry about any of those settings. So we'll just leave that at 0. And then clear buffer when loading the file. So yeah, we're going to clear buffer with default. You can also just do FF, because you can see that's the default here. But we can see that's default, so we'll just leave it. Hopefully that makes sense. So yeah, we're just going to leave all this stuff default and hit OK. And you can see that all of the data for this cartridge is loaded into the buffer. So yeah, so we've got our data here, and all we need to do is write it. So to write the data, you go to Program up here, this P on top of a chip, and then you hit Program. And you'll see that the right light is going here, and it goes along, and it's done. And what it does is it automatically verifies that the code is correct. So yeah, we're done. So hit cancel. And we can even go and do another verify if we want. So we can hit verify, and what it'll do is it'll verify that the code here in the buffer is the same as what's on the chip, and it is. So yeah, we're done. Now we can take this chip out of the ZIF socket, and we now have a ROM chip that has some code on it.